Hi students, in the previous session we learned about the plane mirror where the reflecting surface is flat and smooth. In this session we will learn about spherical mirrors where the reflecting surface is a part of a hollow sphere of glass. That is why it is called spherical mirror. Look at this diagram. You can see a hollow sphere and this part forms a mirror and this part also forms a mirror. When you look this side, you can see that the reflecting surface is curved inwards. If the reflecting surface is curved inwards, then you call that mirror as concave mirror. When you look at this side, the reflecting surface is curved outwards. This type of mirror is called convex mirror. Since the reflecting surface is curved inwards or curved outwards, spherical mirrors are also called curved mirrors. Spherical mirrors are of two types, concave mirror and convex mirror. For concave mirror, the reflecting surface will be curved inwards, whereas for convex mirror, the reflecting surface will be curved outwards. Shade the other side. The one which is shown in green color is the reflecting surface and this is the other region, the one which is shaded. For this convex mirror, you must shade inside. This is the other region. The green color shows the reflecting surface. This is how you draw a mirror. You can see from this diagram, for a concave mirror, this is the reflecting surface and the other side is shaded. For convex mirror, this is the reflecting surface and the other side is shaded. This concave mirror looks like a cave. The incident light rays always falls on the reflecting surface. These are incident light rays. Spherical mirror is a mirror with the reflecting surface will be either concave or convex and forms a portion of a sphere. Now let us learn some of the terms of spherical mirrors. The first term what we are going to learn is pole. What do you mean by pole of a mirror? Pole of a mirror is the center of spherical surface of the mirror. Suppose this is a concave mirror. This is the spherical surface. The center. This is the center of that spherical surface. It is denoted by the letter P. And it is known as pole. Pole of a mirror. You can see from this diagram, this is the pole of the concave mirror. For the convex mirror, this is the pole. What do you mean by aperture of a spherical mirror? Let me draw 3 concave mirrors. Say this mirror to be mirror 1 and this mirror to be mirror 2 and let this be mirror 3. Aperture of mirror 1 will be this much region where it is exposed to light. Therefore, you can call the aperture is this length. That means the length of that spherical mirror, or you can say the diameter of the spherical mirror. For this mirror too, the aperture will be this much. For Mirror 3, this will be the aperture. From the diagram you can see the aperture is small for this mirror 3. Aperture is the diameter of the reflecting surface of the mirror. In this diagram, this is the reflecting surface. This region is the reflecting surface, and that diameter is called as aperture. What is center of curvature and radius of curvature? You know that mirror is a part of a hollow sphere. The center of that sphere is called, this is the center. The center of that sphere is called the center of curvature. It is denoted by the letter C. What is the midpoint of the spherical mirror? This is the spherical mirror. Midpoint is known as pole. Pole of the mirror. This is the pole. Radius is the distance between the center of curvature and the pole. You can easily remember in such a way. Center of the hollow sphere is known as center of curvature, whereas the radius is known as radius of curvature. Radius of curvature is denoted by letter R. This is the radius of curvature. Center of curvature is the center of the sphere of which the mirror is a section. This is the center of curvature. Radius of curvature is the radius of the sphere of which the mirror is a section. This distance, this is the radius of curvature, denoted by the letter R. Next term is principal axis. What is principal axis? Principal axis is the imaginary line passing through the center of the mirror and the center of curvature. This is a concave mirror and this is the midpoint or center. You can call optical center of that concave mirror. It is denoted by the letter P. That means pole of the mirror. This is the center of curvature of the mirror. The line, the imaginary line which you draw between this center of curvature and pole. That is, this line is called as principal axis. In the next slide, we will see about this principal focus which is lying on the principal axis. Principal focus is indicated by letter F. Now let us learn what is principal focus. Now we know that the principal focus lies on the principal axis. What is this principal focus? Let this be a concave mirror and this be the principal axis. Let this be an incident ray which is parallel to the principal axis. When it strikes at the mirror, this ray should reflect back. This reflects in this manner. Similarly, all the incident rays parallel to this principal axis after reflection will pass through this point, and that point is called focus, where all the light rays after reflection meets. It is called principal focus. Concave mirrors are known as converging mirrors because after reflection all the light rays will converge to a point, whereas convex mirror is known as diverging mirror because the reflected rays will diverge. Concave mirrors are known as converging mirror, whereas convex mirror is known as diverging mirror. Principal focus is the point on the principal axis at which the light rays which are parallel to the principal axis converge, or from which they appear to diverge after reflection. The principal focus is lying on the principal axis. This is a concave mirror. This is the principal axis. These are parallel rays which is parallel to the principal axis. Let this ray be ray 1 and this ray 2, ray 3, ray 4, ray 5. Ray 1 strikes at the mirror at this point and it is reflected in this way. Ray 2 strikes at this point and it is reflected like this. You can see it is meeting at the focus. This is ray 3 which is reflecting like this. This is ray 4 reflecting like this. This is ray 5 reflecting like this. All these reflected rays meets at focus F. This is in the case of a concave mirror. That is why concave mirrors are called converging mirrors. All the rays are converging to this point, which is called focus. But if you look into this mirror, which is convex, you can see the incident rays. These are incident rays. Let this be ray 1, this 2, 3, 4, 5. All parallel to the principal axis. After striking at the mirror at this point, so let this be the point for ray 1. It is reflecting in this way. Ray 2 is reflecting in this way. Ray 3 in this way. Ray 4, ray 5. When you extend this rays backwards, you can see it meets at this point F. You extend these rays backwards. It appears to these rays, all these rays appears to diverge from this focus. That is why it is called as diverging mirror. Convex mirrors are known as diverging mirrors, whereas concave mirrors are known as converging mirrors. In the next slide, we will see this small f. What is this small f? This small f is called focal length. Focal length is the distance between the pole and the principal focus. This is the pole of the mirror and this is the focus. This distance, the distance between the focus and this pole, this distance is known as focal length. It is denoted by small letter f, whereas the principal focus is denoted by capital F. F is equal to R by 2. F is the focal length, R is the radius of curvature. Radius of curvature is the distance between C and P, between the center of curvature and pole. That is radius of curvature. You can see principal focus lies at its center. Focal length F is this distance. This distance is the focal length F. Therefore, F is equal to R by 2. The terms we learned in this spherical mirrors are pole. What is pole? Suppose if this is a concave mirror, that midpoint or the center of that spherical surface, that is called pole. What is aperture? The length of this spherical mirror or this diameter is known as aperture, where the light rays can fall. Center of curvature is the center of the sphere of which the mirror is a part. Radius of curvature is the distance between the center of curvature and pole, or the radius of the hollow sphere. Principal axis is the imaginary line which is passing through the center of curvature and the pole. Principal focus is the point on the principal axis where the reflected rays converge. This is the principal focus. All the reflected rays will converge at the principal focus. It lies on the principal axis, and the distance between the principal focus and the pole of the mirror, this is the pole and this is the focus. This distance is known as focal length. We will continue with the image formation of spherical mirrors in the next session. See you.